Welcome to video 8.3b, proving triangles similar. All right, here's example 2. I'll mark it up as we go. LP is perpendicular to EA. I'll put right angle marks right there. N is the midpoint of LP, so I'll mark that up. And P and R trisect EA. So what I'll do is I'll just mark it up like that. And what I want to do is prove that this triangle is similar to this triangle. Not congruent, obviously, but similar. All right, once you start seeing things like midpoint and trisect, you should be thinking about side lengths and proportionality. Okay, if all you got is angles, then you're hoping for angle. So there's a good chance I'll be using either SSS or SAS. Since I've got these angles here, perhaps SAS similarity is where I'm heading. So just right off the bat, that's what I'm thinking. Let's see how I can get there and then finish up with the proof. Okay, so I definitely have this angle congruent to this angle. Now I've got the sides. So for the small triangle, hopefully you guys could see that this side is 1/2 of that side. Okay, because if we got a midpoint, it chops up into two congruent parts. Over here, take a look at this. This is the confusing part. I've got trisecting, so I've got I've got 3 congruent segments, but this one chunk, as compared to these two, is also in a 1:2 ratio. I've got 1 part versus 2 parts. So I am going to be able to use SAS triangle similarity. So now that I have a game plan, let's write it down on paper. And again, I'm going to go in SAS order. So I'm going to start with the sides. I'll start with the easy ones. So I'll start with this. So N is the midpoint of LP. That was given. Based on that, I can say the following. I can say NP, or PN, however you want to say it. I'll say PN equals 1/2 of LP. And my reasoning is going to be, if I've got a midpoint, then 1 part is 1/2 of the whole. Then 1 part is 1/2 of the whole. We're just not used to writing it that way. You could have also said 2 congruent segments, but this kind of better alludes to what I'm writing there. Okay, so that's the sides being in that 1/2 proportionality. Now I'll go for the angles. That's easy. I'll use this. LP is perpendicular to EA. That was given. That's going to mean angle EPN and angle APL are right angles. If perp, then right. And then, of course, if right, then congruent. Angle EPN is congruent to angle APL. If right angles, then congruent. So that's the angle being congruent. Then I've got to get the other sides. I'm going to use this information right here. P and R trisect EA. That was given. Then, as I alluded to before, I'm going to say EP equals 1/2. I could say AP or PA, whatever. I'll go PA. And again, I'll say if trisect, then 1 part equals 1/2 the other 2 parts. if trisect, one part is half the sum of the other two. Again, it's that 3 congruent segments. Okay, so now I've got side, angle, side. What's important to note is I've got that same half in each proportion. So now I can say triangle pen is similar to triangle pel. It's kind of funny, pen pel. And that would be side, angle, side. I do need you to put the tilde mark so I know it's not congruence. Side, angle, side, similarity. So there you have it, another proof on proving triangles similar.